Welcome back to the Deep Dive. Today we're starting with something that really flips the script on secure computing. When you think decentralized networks, you picture huge server rooms, right? Racks and racks of hardware. But what if the real power, the truly trustless compute, wasn't there? What if it was actually in, like, the phone in your pocket? Or maybe that old one sitting in your drawer?
It's a huge shift in thinking, absolutely. Moving the actual foundation, the infrastructure layer, away from those big corporate data centers and onto, well, regular mobile hardware.
We're diving deep into Acurast today. They're making this claim, right, that they're the real decentralized compute network, and it's all built using spare smartphone capacity. Exactly. So our mission here is to really get under the hood of what they've built. We've got a ton of source material here that lays out the why. The technical reasons why a smartphone might actually be better for certain secure tasks than a big server, which sounds kind of wild at first. We'll dig into the economics too, the incentives, how people actually participate, and look at the applications they're enabling right now. Things like secure AI for businesses, blockchain indexing, all sorts of stuff.
And you really have to start with their core idea. Acurast isn't just adding more cloud options. It feels like they're fundamentally rethinking decentralized compute, starting right at the hardware level, using that hardware itself as the source of trust. It's a very deliberate, security-first approach. It kind of turns the usual cloud model upside down, relying on standard features we all carry around.
Okay, yeah, let's unpack that. Section 1, the foundation. This move from, massive enterprise servers, super expensive, need physical security, all that, to just a regular phone. The sources keep calling the smartphone the new foundation of the decentralized compute. So why? Why bet everything on hardware lots of people see as, well, disposable?
It does seem counterintuitive if you're just thinking raw speed, maybe. But the rationale we're seeing in the material, it's almost entirely about security and standardization. They call smartphones the most battle-tested devices worldwide, trusted by billions. Just think about that scale for a second. Billions of devices, all running really advanced silicon that gets updated constantly.
But hang on. Surely a dedicated server locked down behind, multiple security doors and biometric scanners is safer than my phone.
Yeah.
I can leave my phone in a cab.
Right. That's the old model, isn't it? Trusting the building, trusting the company running it. Acurast's approach is different. It's about trusting the chip inside the phone. They argue that standard mobile hardware has these two critical technologies built in, things that generic servers often either lack or don't implement as well. Trusted execution environments, TEs, and really good hardware security modules, HSMs. These are like cryptographic guarantees built right in at the factory.
Okay, TEs. Let's pause there because that seems super important. Lots of us have probably heard the term. But what does a TE actually do that makes it more secure than just, the regular phone operating system?
So think of the T as like a secure vault built right into the main processor, a completely isolated area. When you run sensitive code or handle sensitive data inside this TE, it's totally walled off from the normal operating system, Android, Linux, whatever. It's even separate from the low-level firmware. Crucially, even if the main OS gets compromised, maybe by malware, the stuff running inside the TE, it stays protected. It gives you cryptographic isolation, even from the person holding the phone or from hackers.
Wow, okay, so the network isn't trusting the phone's owner or even the phone's main software. It's trusting the integrity of this TE section, which is basically verified by the chip maker.
Exactly. And that isolation gets another boost from the second piece. The HSMs, the hardware security modules, TEs give you the secure running environment, but HSMs are specialized little processors just for securely managing keys and secrets. Think passwords, cryptographic keys, that sort of thing. If you're doing anything with finance or sensitive data, you need rock-solid key management. And the fact that good HSMs are standard in modern phones, that provides a really strong base for holding the secrets needed to, say, sign a transaction or decrypt data for a job.
That makes a ton of sense, yeah, especially when we get to the finance use cases later. But, okay, let's address the elephant in the room, reliability and speed. Data centers are built for 24/7 uptime, low latency. Phones, they run out of battery, they lose Wi-Fi. How does Acurast deal with that? Seems like a major hurdle for using mobile hardware.
It's definitely a challenge, right? The answer seems to be twofold, based on their model around stakes compute and verifiability. First, the economic incentives, which we'll get into, heavily reward providers for being online and reliable. There's a strong push to keep that phone running the tasks. Second, the tech itself compensates for the fact that any one phone might be unreliable. It does this by focusing intensely on verifiability and using lots of redundancy. They're not trying to beat a server on how fast it does one thing. They're competing on whether you can prove it was done securely and on having providers spread out everywhere.
Right, and that connects directly to this key phrase they use, verifiable decentralization. That feels like the big leap. How do I, as someone paying for a confidential task, actually know it ran securely inside the T of some random phone in, say, Brazil, and wasn't just faked?
Okay, this is where the T integration really shines. It uses something called remote attestation. When a task finishes inside the T itself generates this cryptographic report. It's like a signed receipt, tamper-proof, signed by the phone's secure hardware keys. This report proves 3 key things to the network. 1, the code that ran was exactly the code you sent. 2, it definitely ran inside an approved T. And 3, the hardware itself is genuine, not some emulator.
So wait, the whole security model flips.
Mhm.
Instead of trusting physical locks and guards, you're trusting this cryptographic proof generated by the standard chip itself. The phone isn't just doing the work, it's proving it did the work securely.
Precisely, which means the network can actually handle phones occasionally dropping offline, because it only accepts results that have this verified, signed attestation from the T. If a result comes back without that cryptographic proof of secure execution, it just gets ignored, thrown out. This keeps the whole network trustless, even if individual providers aren't perfectly reliable, because the output is guaranteed.
Okay, this is getting really interesting. We've got the foundation, the smartphone with its TEE and HSM, providing this verifiable security. Now let's talk about what you can actually build on that. What does this network do? The sources lay out 4 main areas. Let's start with confidential execution.
Right, confidential execution. This seems like the most obvious high-demand use case right now. It directly tackles that huge problem companies have with AI. How do you process sensitive data securely?
The top example they give is confidential LLMs, large language models for enterprise data. Can you walk us through that? Like, why would a big bank use this network of phones instead of, I don't know, a super secure private cloud they set up themselves?
It comes down to verifiable trust again. Even in a private cloud, the bank ultimately has to trust the cloud provider, right? Trust that they aren't looking at the data, that their admins are secure. Let's say the bank wants to run some fancy AI risk model on its customer transaction history. They absolutely cannot let that data leak. With Acurast, they could send the AI model itself plus the encrypted customer data to this decentralized network of Ts. What they get back is the result, along with that cryptographic proof, the attestation that it ran correctly inside the secure Ts. Critically, the person whose phone actually did the computing, they never saw the raw bank data. It stayed encrypted outside the TE. And the bank knows cryptographically that the AI ran as intended in isolation.
That's a massive difference. You get the power of AI without the compliance nightmare or the data exposure risk. And this extends to other things too, right? Like distributed analytics, secure database stuff.
Yeah, exactly. Think about distributed analytics. Suddenly, it becomes much easier to be GDPR compliant, for example. You could analyze data sitting in different countries without ever needing to bring all the raw personal data together in one place. The calculations happen securely, in isolation on phones within those regions perhaps, and only the final aggregated non-sensitive result comes back. That solves a huge headache for global companies.
Okay, moving to the second capability, decentralized bandwidth and compute. This sounds less about keeping secrets and more about just using the sheer number and spread of all these phones.
Right. Here, the fact that the phones are everywhere is the main advantage, especially for tasks where having lots of different IP addresses matters. Take web scraping or blockchain indexing. If a big company tries to scrape a ton of data using AWS or Google Cloud, what happens?
They get blocked almost immediately. The website sees a flood of traffic from one place and shuts it down.
Exactly. But if you use thousands of phones spread across the globe as the compute providers, each request comes from a totally different regular mobile IP address. It makes the scraping much harder to detect and block, so you can reliably gather data for market research, academic work, whatever, without getting constantly rate limited. It's resilient bandwidth.
And that distribution must also help with oracles, right? Those things that feed real-world data into blockchains.
Oh, absolutely vital. Centralized oracles are a huge weak spot. If your price feed relies on one company's servers, that's a prime target for attacks or just downtime. Spreading the Oracle job across many TE-verified mobile providers makes it way more robust. You get better security, potentially faster updates, and trust in the data because you know it was sourced and processed securely inside those TEs. Plus, they mention using this for decentralized VPN services. Basically, using these distributed phones as secure exit points around the world gives you loads of anonymity and location flexibility.
Okay, third area, On-chain automation and secure secret management. This sounds like it's getting into serious financial applications, high stakes.
Definitely. And this is where having both the TE for secure execution and the HSM for secure key storage becomes absolutely critical. Non-negotiable, really. We're talking about running financial logic, handling private key stuff, where if it goes wrong, money is lost instantly and forever. The examples listed are things like AI-driven training strategies for both centralized CEX and decentralized DEX exchanges. Imagine you've got a secret, complex algorithm deciding when to buy or sell crypto based on market signals. That logic itself is valuable IP, and it needs to run privately and perfectly.
And crucially, it needs to actually make the trade using the user's private key, which has to be guarded like gold.
Yes. So the AI model, the secret trading logic, runs inside the TE. The phone provider can't see it or steal the strategy. At the same time, the user's private key needed to sign the transaction, protected by the HSM. This architecture means the trade execution is secure, it's confidential, and it's provably correct before it even hits the blockchain. That's a level of trust you just don't get easily with traditional servers.
And other uses here. Cross-chain asset management. That sounds complex and definitely needs secure key handling.
For sure. Moving assets between different blockchains securely is tricky. And they also mention LLM-powered crypto wallets. That points to a future where you could maybe talk to an AI and it could manage your crypto portfolio, execute trades, manage risk, all based on your conversation. But for anyone to trust that, you need absolute certainty the AI can't access or leak your private keys. The THSM combo provided by Acurast is what could make that possible.
Okay, last one. High-performance distributed compute. This sounds a bit like a contradiction. How do spare phones give you high performance? Is this just about adding up lots of small bits of power?
It is, yeah. The performance comes from doing things in parallel across many, many devices, not from one super fast device, born as in a supercomputer, obviously, but thousands of them working together. That can create really cost-effective compute clusters. And because it's distributed, it's naturally resilient. If one phone running a piece of your website goes offline, there are thousands more ready to take over instantly. It's robustness through decentralization.
And the really demanding application they mentioned is scalable ZK-proof generation, zero-knowledge proofs. Those are super important for privacy on blockchains, but they take a ton of computing power to create.
Yeah, ZK proofs involve massive calculations, lots of matrix math. It's perfect for parallel processing. By spreading that heavy cryptographic workload across the Acurast network, they can offer a way to generate these proofs that scales up and, crucially, is verifiable. You know the proof was generated correctly within the T's. This could make advanced privacy tech much more accessible and affordable because projects wouldn't need to build their own huge, expensive server clusters. It's tapping into that unused, secure processing power already out there in people's phones. A great example of using that distributed scale securely.
Okay, that transition from the tech to the why is key. We know what it can do and how it's secure, but Section 3 gets into the economics, what makes people actually provide their phones. This is where it gets really interesting, right? How do they reward providers enough to make it worthwhile?
Right. The sources show this really clear two-sided approach. You either need compute, you're a developer using the network, or you have a spare phone. You're providing compute and earning rewards. And the economic model, which they call staked compute, seems heavily designed to incentivize and grow that supply side. Massively, actually.
Okay, talk about that incentive, the inflation allocation.
Yeah, this really signals how important getting those phones online is to them. The source material is explicit. Staked compute gets the lion's share of the network's inflation, 70%.
70%, wow.
70% of all new tokens created go directly to rewarding the compute providers. It's not just a bonus, it looks like the absolute foundation of their tokenomics.
That is a huge number, clearly designed to attract a ton of hardware onto the network. But you have to ask, is 70% inflation sustainable in the long run? Or is this mainly just to get things going? What about dilution for people holding the token but not running a phone?
That's the classic challenge for any utility network like this, isn't it? That 70% figure definitely screams bootstrapping phase. Right now, securing that reliable, attested mobile compute supply is clearly seen as way more valuable than worrying about initial dilution. It's a signal. The network is only useful if it has that secure supply. So the rewards are super high up front to get people over the hump, downloading the app, keeping the phone charged and online. Presumably, as the network grows and starts generating more income from actual usage fees paid by developers, they could potentially dial back the reliance on inflation. But for now, it's all about getting volume and verified providers.
Makes sense. Paying a premium for something new and valuable, that verifiable, secure compute. What's also interesting is what they call the accessible first design. They say you can onboard a phone without buying tokens first, no gatekeepers. How big a deal is that low barrier to entry?
Oh, it's huge for getting truly global scale and decentralization. If you made people buy a bunch of tokens up front, who could participate? Mostly people already active in crypto, probably concentrated in certain countries. By removing that initial cost, they open it up to basically anyone, anywhere who has a compatible phone. That dramatically increases the potential number of providers and spreads them out geographically. You just need the right hardware, not a pile of investment cash, to start earning from that 70% inflation stream.
That's clever, a way to source hardware globally. But what if I like the project, want to support it, maybe earn some rewards, but I don't actually have a spare phone that meets the specs?
That's where delegation comes in. It creates this really neat partnership. If you have tokens but no phone, you can delegate your stake to someone who does have a phone. You become a delegator. You're essentially providing the collateral, the security deposit that allows the phone provider to take on bigger, maybe riskier, higher paying jobs.
And the compute providers, the people running the phones, they benefit too by accepting delegation.
Exactly. They get more security backing, which makes them eligible for better jobs, and they earn extra rewards on top of their base allocation, sharing some of that upside with the delegator who provided the capital. The sources also mention restaking is possible for this staked compute. That suggests you can compound your earnings and maybe unlock more options if you're committed long-term to providing reliable service. The whole system seems geared towards rewarding the act of supplying secure mobile compute, whether you bring the hardware or the capital.
Okay, so moving from the token numbers to the people involved, we need to talk about the community side, which the sources paint quite vividly as the cloud rebellion. That sounds way more exciting than just, running an app for tokens.
Yeah, the Cloud Rebellion is their main engagement platform, and it's definitely gamified. It turns the process into this kind of ongoing mission or campaign. It's described as a quest platform. Participants do tasks, they earn Mist, which seems to be the Rebellion's own reward currency, and they climb ranks. It adds that layer of fun, competition, achievement, probably helps a lot with keeping people engaged compared to just a flat payment.
And the fact that, according to the sources, Season 4 is live right now, that shows it's not static, it's constantly evolving. So if you sign up to be a rebel, how do you actually earn this Mist? What are the main ways to get involved?
They list 4 main ways to earn Mist and contribute. First, just completing the quests on the platform could be tutorials, social tasks, that kind of thing. Second, actually deploying apps onto Acurast's decentralized cloud using the network. Third, and this is the core bit, onboarding a mobile phone as a processor, actually supplying that verifiable compute we've been talking about. And fourth, pretty standard but effective, referring friends to grow the network organically.
It really is turning compute supply into a community game. That's smart for keeping people involved and building loyalty. And looks like they have a solid support structure too. Ambassador program, community hub, active on X, Twitter, Discord, Telegram, GitHub, YouTube, the works. They're building an actual ecosystem.
Definitely. And that ecosystem seems to be supporting real growth. The sources use placeholders, like Map+4, for the exact numbers, but they track onboarded phones, compute deployments, and on-chain transactions processed. The key thing is that all 3 metrics are shown as growing together. That suggests they're successfully getting the supply phones, encouraging usage deployments, and seeing actual activity transactions. The momentum seems to be building across the board.
And we can actually see that momentum playing out recently. Looking at the dates on the announcements and blog posts in our sources, there was a real flurry of activity around September and October 2025. It gives you a sense of them hitting major milestones, moving from testing towards full launch.
Absolutely. That late 2025 period looks like a critical ramp-up phase. October 9th, there's a recap of Loot Boxy's Drop 4 that ties right back into the gamified Mist rewards. Just before that, October 3rd, they published the complete guide to collecting Mist, explaining exactly how rebels earn rewards.
And September 2025 looks like it was massive. Huge news drops. The Acurast Association announced the actual launch date for the token generation event, the TGE, on September 30th. That's the moment the token becomes real, tradable, the economics go live.
Yeah, and leading up to that TGE, they made sure to reward the early community. They announced the Cloud Rebellion airdrop on September 25th, specifically for those rebels who helped test things and provide early supply. Around the same time, September 23rd, there was also a key technical update. From Canary to Mainnet, CACU to ACU conversion, detailing how early participants move to the final token, shows they're managing that transition carefully.
And look at this, also September 23rd. A partnership spotlight. Acurast and Beamable, exploring secure, scalable game validation. That ties right back to the use cases we discussed needing that high-performance, verifiable compute for things like gaming.
That beamable partnership is really interesting. Game validation, anti-cheat systems, these need absolute trust and security. Partnering with a gaming platform suggests Acurast feels their TE-based model is ready for demanding real-time industry applications. Seeing all these dates clustered together really shows them shifting gears rapidly from testing to a live, economically active network, heavily fueled by those staked compute incentives.
Okay, so let's pull it all together. What does this actually mean? We've gone from the secure hardware and phones, the TEs, up through the 70% inflation driving participation, the gamified cloud rebellion. What's the big picture here? It feels like the really revolutionary part isn't just decentralization, it's doing it with verifiable trust, using hardware most of us already own, the smartphone.
I think that's right. It's combining decentralized scale with these standardized, almost military-grade security features that happen to be built into consumer devices. They're kind of weaponizing in a good way the security of modern phones against the old model of opaque, centralized clouds. It tackles scalability, sure, but also access, and most importantly, that verifiable trust in the computation itself, something traditional clouds just don't offer in the same way.
The idea that your old phone could run a confidential AI model more securely with actual proof than some custom server in a locked room, that's the real mind-bender here. It makes high-security computing potentially accessible to anyone.
And it has huge implications beyond just Acurast. It really challenges the economics of enterprise IT. If smartphones, affordable, standardized, billions of them out there are proving they can be high-security compute providers today, it really makes you wonder, doesn't it? What's the long-term future for specialized, expensive corporate data centers that often lack these standard, built-in crypto security features?
Is the future of computing less about giant capital investments and more about tapping into the secure hardware that's already spread across the globe? Maybe you should dig out that spare phone and check out the Rebellion. Thanks for joining us for this deep dive.
My pleasure. Always fascinating stuff.